Okay, in this video, we're going to look at driving a stepper motor with the Arduino Nano. So what you'll need is an Arduino Nano module and a driver chip, and I'm using the ULN2803, which is a Darlington driver. So there's 8 open collector Darlington transistors on this chip, and we're only using 4 of them to drive the 4 phases of the stepper motor. So you'll need 4 GPIO pins from the Nano feeding the driver, which will feed a stepper motor similar to this Unipolar stepper motor. Okay, this is the stepper motor that I'm using. It's made by Airpacks. It runs on 12 volts DC and it has a step angle of 7.5 degrees, which works out to 48 steps per revolution. Now this is a unipolar stepper motor, so it has 2 main coils. There's an A coil and a B coil, and they're stacked on top of each other, so there's your A coil and your B coil. Now each one of these coils has 3 wires coming out of it, so this stepper motor has a total of 6 wires. Now one of the 3 wires of each coil is a center tap, and they're joined together and fed into the 12 volts power supply. So we're left with 4 phase control leads, which are driven by the Arduino Nano. Okay, here's the schematic diagram of the stepper motor that I'm using. Now we can see the 2 main coils that were stacked as coil A and coil B, and each coil has 3 wires coming out of it, 3 leads. So there's your 1, 2, 3 leads coming out of each coil. Now each coil has a center tap, and they're joined together and fed to the 12 volt power supply. So if we ground this lead here, which is the phase 1 lead, we'll energize the phase 1 coil, which will be this coil here. And if we ground this lead, which is phase 3, we'll energize this coil, which is the phase 3 coil. So if we ground this lead here, we'll get current from the 12 volt power supply through the center tap, through the coil, and into ground. So if we energize phase 1, and then phase 2, and then phase 3 and phase 4, the stepper motor will turn clockwise. And if we energize phase 4, then 3, then 2, and then 1, the stepper motor will run counterclockwise. But this is called a single phase full step. Now there's other ways to drive this stepper motor. We could use a dual phase full step and a half step. And we'll look at that later on in this video. Okay, here's a diagram showing 3 ways in which we could drive the stepper motor. Now the first one is called a full step, single phase. You can see in the diagram, we energize 1 phase at a time. So we go phase 1, phase 2, then phase 3, and phase 4, which is pretty simple. So if we energize it in that sequence, it'll rotate clockwise. Now the second technique is called the full step, dual phase, where we turn on 2 phases at the same time. So we start out with phase 1 and 2 on at the same time, then 2 and 3, then 3 and 4, then 4 and 1. And if we do that sequence, it will rotate clockwise. Now with this full step dual phase, we have a higher torque because we have 2 phases on at the same time. Now this takes more current, but we have a higher torque on the stepper motor. Now the third way is called the half step, which we dovetail the first 2 steps. So we have 1 phase on, then 2 phase on, then 1 phase, 2 phase, 1 phase, and that alternates. That gives us more precision because now we're doubling our steps. So we have a little bit more precision, but it doesn't have the same torque as the second step. So these are 3 ways in which we could drive our stepper motor, and we'll look at some software where we could actually do this, the 3 techniques of driving the stepper motor. Okay, here's a schematic on how to drive the stepper motor, and you can see the 4 GPIO pins on the very left feeding the ULN 2003. Now I'm using the ULN 2803, and you could use both. And you see the 4 phases coming out of the driver into the stepper motor, and the stepper motor is driven by 12 volts. So that's a very simple schematic, a very simple setup to drive the stepper motor from the Arduino Nano. Okay, here's the code running on my Nano to drive the stepper motor. And I'll demonstrate the 3 different ways to drive the stepper motor. So the first thing you see here, I'm setting my GPIO weighting to 8421, which corresponds to phase 1, 2, 3, and 4, and that's my single phase sequence. And the next bit of code, I'm weighting my GPIO lines to 9, 12, 6, and 3, which will give me phase 1 and 2, 2 and 3, 3 and 4, and 4 and 1, which is my double phase sequence. Now my next word is called kill. That will de-energize all coils. So take the power away from all the coils. And the next word is energize. So if I type phase 1, then energize, I'll energize phase 1. And if I type phase 1 and 2, then type energize, it'll energize phase 1 and 2. So my first control word is called single. That's my single phase full step. And that's a begin and until loop. And the first thing it does is it energizes phase 1, then waits till 10 milliseconds, then it energizes phase 2, then 3, then 4, and that does that in a begin and until loop. So the motor will run continuously clockwise until any key is pressed on the keyboard, then the motor will stop. And then all coils will be de-energized by the kill word. So that's your single phase full step. Now if we go to the next word called dual, this is my dual phase full step. So it's very similar. We got a begin and until loop. And the first thing it does is energize phase 1 and 2, and then 2 and 3, then 3 and 4, and then 4 and 1. And it does that in the begin and until loop. So the motor will run clockwise until I hit any key, and then it will kill all coils. So this is the dual phase full step. So that's the one with the maximum torque, and that's the one I use the most. Now the last one is called a half step mode, where you dovetail the first two techniques. And you can see we got twice as many steps. So we dovetail, so we alternate between phase 1, and then we go to phase 1 and 2, and then phase 2. So we alternate between one phase and two phases, and we go into a begin until loop. Same sort of deal as the other two, until any key is pressed. So that's my half step mode. It's more precise, but it doesn't have the torque as a dual phase full step. So in the rest of the video, we're going to use a dual phase full step. I'll demonstrate other ways to control the stepper motor. Okay, I'm going to run a little demo program. Now, this program is written in Forth. Now when you program in Forth, you're basically creating your own little language. So this would be like a stepper motor controller language. So I'm going to send it some sequence programming. And the first thing you're going to see, it's going to rotate clockwise for 2 rotations. And then 4 steps. And then 12 steps. Then change direction to counterclockwise and go 12 steps. Then 24 steps. And then 4 rotations. And change direction to clockwise and rotate 180 degrees. And then change direction and rotate 90 degrees. And rotate 3 rotations. And then stop. So there's a little example how you could program a stepper motor using the Forth programming language. Okay, I just want to demonstrate the torque difference between a single phase and a dual phase sequence control. So I'm going to run this motor with a single phase program. And you can see how easy it is to stop it. So I could stop it pretty easy, because it has low torque. That's a single phase. I'll run a dual phase program. That's dual phase. And it's a lot harder to stop. Very hard to stop. There it is right there. I have to press pretty hard. So there's actually a big difference between the single phase and double phase sequence control. So I hope this video gives you guys some ideas how to control your own stepper motor with our Arduino Nano.